So we'll mark these 2 points A and B, and this is the distance we need. I'll call that D kilometers. And A leaves at 1 p.m. This motorbike moves towards B at a uniform speed. Car leaves at 2 p.m., so 1 hour later. And the speed is double that of the motorbike. So let's call that 2R, and the rate of the motorbike is R. And so in 1 hour, it's moved R kilometers. So that remaining distance, because this is at 2 p.m. here, is D minus R. And now they're both driving towards each other. And so I can just combine the rates, R plus 2R, times the time it would take to cover that distance. That would be when they would meet each other. And they meet at 3:40 p.m. So 1 hour, 40 minutes. So this is 1 plus 40 over 60, or 1 plus 2/3, or 5/3 of an hour. So that's 5/3. 5/3 of an hour. And at a point which is 168 kilometers from A. So that would be, let's say this is 168 kilometers. So actually, maybe I should have set it up that 168 kilometer would be the total distance traveled by the bike. So it would do in 1 hour R kilometers, plus in that 5/3 of an hour at the rate R. So yeah, actually, I don't know if you need this. Maybe I'll come back to that. So 8 over 3R, so that would give me R. 63 kilometer per hour. Questions, what is the distance between A and B? So yeah, I can plug that in and figure out D from this. So 3 times R. Maybe there's a simpler way and this wasn't necessary, but I think this will work. 21, 63 times 5 plus 63 is D, which is really 63 times 6, which is 1. I get 378 kilometers, choice B.